Assalamualaikum dear students. In today's class we are going to complete the isomerism series. In last class we were discussing about the isomerism, the definition first. What actually isomerism is: the two compounds having same molecular formula but different chemical structures. If the chemical structure is different and the molecular formula of two compounds are same, so they are known as isomers. And we discussed about the different type of isomers: constitutional, chain, position, functional, in last video. So if you haven't gone through that, visit that video first so that you can understand about the isomers, and then we will move towards the type of isomers. In last video I told you the isomers are further divided into two types. It is dependent upon the connectivity. Like we took the example of C5 and H12, that is pentane. In pentane there are 5 carbons, so these 5 carbons can be arranged like this: 1 2 3 4 5. Carbon number 1 2 3 4 and 5. If they are arranged linearly, it would be n-pentane. But if I want to change the connectivity, I can place 4 carbon in chain 1 2 3 and 4, and the 5th one I'm going to connect with the second carbon. So it is now with same molecular formula C5H12, but the connectivity of atoms is different. So structure A and B are constitutional isomers. When the compound having same molecular formula but their connectivity or the chemical structures are different, so they are known as constitutional isomer. Let one more example of constitutional isomer. If we have 3 carbon in chain and 2 in branch, again there are 1 2 3 4 and 5 carbon. So the formula is C5H12, but in structure C, A and B, the spatial connectivity is different. In structure A, all are linearly arranged. In structure B, there is 1 branch, and in structure C, there are 2 branches. So A, B and C are constitutional isomer in which the connectivity of atoms is going to be changed. The stereoisomers are the isomers in which the connectivity is not going to be changed. How? If I take the simple example of C2H2 Cl2, from that molecular formula, if I want to make structure, the simple possible structure would be first carbon connected with another carbon by double bond. Now 2 carbons are fulfilled in chemical structure. There are 2 hydrogen, so I must add 1 hydrogen each side, and there are 2 chlorine, so I am going to add 1 chlorine each side. That is not the final structure. This structure A can also be in another form. Like if I write 2 carbon end-to-end connected, in first Cl and hydrogen, in second Cl and hydrogen. So can you observe what is the difference between structure A and structure B? Here we have same molecular formula, same connectivity, 2 carbons end-to-end connected in A, 2 carbons end-to-end connected in B. On carbon number 1 there is chlorine and hydrogen. On carbon number 2 there is chlorine and hydrogen. Another side of structure A is also having chlorine and hydrogen. In B structure, chlorine and hydrogen are also present. But what is the difference over here? In A and B, the spatial arrangement of atoms in space is different. What does it mean? If we check structure A, the 2 heavy atoms or bulky groups are in opposite direction to each other. that structure is known as trans. In structure number B, the heavy group or chlorine are attached on same side, the upper side. This structure is known as cis structure. So A and B are having same molecular formula, same connectivity, but different arrangement of atom, different arrangement of atom in space. That is the definition of stereoisomers. What are stereoisomers? The two different chemical structures having same molecular formula, same connectivity, but different arrangement of atom in space, they are known as stereoisomers.